Hey guys, today I'm going to talk about a very important concept, that is the concept of a orthonormal matrix. Okay, what exactly it is, and there's something really interesting about orthonormal matrix and IIT exams. Okay, so I don't know what is up with these JEE people, whoever is setting up the papers. If you just look through the previous year problems, it seems that they're just obsessed with orthonormal matrices. Okay, both in JEE Mains and advanced. I mean, even without knowing the concept of orthonormal matrix, you would be able to solve many of the same questions. Okay, but they became like way more lengthy than required. Okay, first of all, let me just discuss what the orthonormal matrix is. How exactly can you use it to solve problems, or basically simplify problems where manifolds. Okay, let's get started. Orthonormal matrix. So for example, we are going to take a 3 by 3 matrix. Okay, so the things are much easier. A, B, C, D, E, F, Z, H, I. Okay, yeah. So if you look at the strict definition, it just says that orthonormal matrix is any matrix that has got A transpose times A equal to the identity matrix. Okay, similarly, another definition we can understand from here. Okay, that A transpose equal to identity. Even this will prove that A is an orthonormal matrix. Do you know why is this so? Because we can write A transpose as A transpose times A transpose, and if you compare this with, so I have written this one as this. Okay, and if you compare this thing with this, then you can see that A transpose is orthonormal, right? Orthonormal I'm writing as ON. Okay, so A transpose is orthonormal, but you know what, A must be a square matrix to it to be an orthonormal matrix. Okay, so if you take transpose as well, it basically remains the same if we look at the definition closely. Okay, first of all, I did not even tell you yet what the definition is, but once I tell you the definition, you pretty much see that A transpose and A is pretty much same when it comes to checking for orthonormality. So basically this means that A is also orthonormal. Okay, so let's check the definition from this, the detailed definition from this one itself. Okay, so I am claiming is that if the magnitude of, if we consider a row to be a vector, if the magnitude of the vector is 1, okay, and of any row is 1 or any column is 1, and if when you take dot product between two rows or two columns, you always get 0. Basically in the definition only, it's pretty clear. This is basically orthonormal is basically orthogonal plus normalized. Okay, so what is normalized? Normalized is basically magnitude is made equal to 1. And what is orthogonal? Basically if you take any two row or any two column, they are basically orthogonal, or basically whenever you take dot product between these any two rows or any two column, you always get 0, because as you know, in dot product basically A dot B is A B cos theta, where A B means the magnitude of the vectors A and B. Okay, so when they're normal, cos theta is 90 degrees, so this dot product will be 0. Okay, so let's see what it means, right? A transpose A, if you think about it, A transpose A. Okay, so suppose this is my identity matrix. Okay, why we get the identity matrix? Let's find it out first of all. Okay, so A transpose A, let's call it C. Now let's see Cij. Okay, Cij is basically when you multiply this A transpose with A and take the ith row and jth column, the entry corresponding to ith row and jth column. Okay, let's see what Cij would be. This is basically, if you know the definition of matrix multiplication, the ijth entry of the product is basically the ith entry of the first matrix, ith row. Okay, so I'll just write it as ith row. How do I write it as ith row? A transpose ith row dotted with A jth column, right? Because we are multiplying A transpose and A, I am taking A transpose ith row because this is I, and this A is corresponding to this A, and jth column because I am looking at the jth entry. Okay. Now, do you know that A transpose ith row is same as A's ith column? Because while transposing, we just make the rows columns, columns rows, right? So if you just see this, I can write as A jth column, right? Sorry, ith column. Let me just correct it here because this is really silly. Pencil, and yeah, A ith row, okay, ith row times A jth column. Now let's take two cases when I equal to j and I is not equal to j. Okay, when I equal to j, you can say that I am just taking dot product between the same row, basically ith row of A and ith row of A. And if you take dot product of the same vector, then you pretty much know that A dot A is basically the magnitude of A square, right? And already we know that it is normalized and the magnitude is nothing but 1. Okay, because we have already defined the orthonormal matrix to be like this only. Magnitude of any row or any column is just 1. Okay, so magnitude of A is this is should be just ith row. Okay, ith row equal to 1. If I is not equal to j, as we have already shown that any two different row or two different column, if you take dot product, that would be just 0. So if I and j are not equal, it would be just 0 of C. So if you write this whole C, it would be again a 3 by 3 matrix because A is 3 by 3, or and A transpose will also be 3 by 3, and obviously this is going to be generalized to any n by n matrices if you just want to do that. And now if you look at C is very easy, right? I equal to j is 1, so we just put diagonal entries to be 1 and rest we can just fill them up with zeros, and voila, we got our identity matrix, didn't we? So this is orthonormal matrix. Would you remember now? It's just any two rows or any two columns. If you take dot product, if they're like different, then you get 0. If you take dot product with itself, any rows or any column, basically which is our magnitude, we get that to be 1. Okay, so now let's look at the JEE Mains problem. Okay, so if you know this much of concept, this problem will almost solve itself. Okay, if you do not know this, then you have to go through at least half a phase of computation, and which is very boring and tedious. Okay, A is equal to, let me just change the color, I've been writing with green for ever since. Okay, A is equal to 0 twice Q R P Q minus R, P minus Q and R. This is A. Okay, and given if A transpose is equal to I3, so this is also A would be 3 by 3 matrices, right? Because A is given here. Okay, then modulus of P is, okay, can you already see the answer? This is a JEE main question. Okay, JEE main 2019 problem. Okay, can you already see the answer? it's pretty evident, right? If you look at this particular column, what did I say? The magnitude would be 1, right? Let's because you know why I have chosen this particular column? Because we need to find out the magnitude of P, and if you look at this column, it has got only P's here, right? So it will probably give us the answer. Let's try it out. The magnitude would be P square plus P square plus 0 square equal to 1. Magnitude, you need to take a square root as well, and when you square both sides, then obviously 1 square would be 1 only. So you get twice P square equal to 1. So P equal to modulo P equal to 1 by root 2. I did not even bother to give you the options, right? What the options are? Options are basically 1 by root 5, 1 by root 2, 1 by root 3, 1 by root 6. Okay, and obviously the correct answer is answer B. And if you did not know about orthonormal matrix, you know, if you look at any solution book of this particular problem in the standard available book in the market, or if you are from India, you are obviously understanding. If you are not from India, then you just ignore this part of the video. Okay, so if you look at any solution book, then you can pretty much see that people are taking this A matrix, then transposing it, then multiplying it and equating it with identity and coming up with many equations and then solving them to get the value of P. But just by knowing this orthonormality concept, you can pretty much solve it on your own. Okay, and based on this particular concept, I am going to solve many of the past both JEE Mains and advanced problems, and you can see that how it solves almost all the problems that I am going to discuss in just one or two lines. Okay, so that's it for today. Hope you liked the video. Hope you learned something new and cool or useful. And if you like the video, hit the like button. Please do not forget to subscribe, because it really encourages me to come up with new and cool content just for you. And that's all for the day. Take care. See you in the next video. Bye bye.